welcome to Ethics and Integrity in Research. This is Lesson 4, Part 1, so let's get started. So, a general overview for Lesson 4, we're going to be talking about what are research and ethics and integrity, research ethics committees, how to be an ethical researcher, and lastly, research misconduct and the consequences and how to avoid it. We'll also be covering several examples and some activities. So, I want you to think about what are ethics and what is integrity. Research ethics and research integrity are overlapping themes that are usually talked about together. So, these practices make sure that research is conducted with the highest standards and is also performed with minimal risk of harmful outcomes or consequences. The definition of a research ethics is doing research with responsibility, particularly towards participants, colleagues, employers, funders, and society. Research integrity means doing research in ways that ensure confidence in the results, the researchers, and the research community. These two concepts are distinct, but they affect each other. For example, from poor data management not only undermine the confidence in the research, which is a breach of integrity, but are also the lack of responsibility towards participants and funders, which is a breach of ethics. So, why is research ethics and research integrity so important? Research ethics helps to create safe, reliable, and experimental designs for different types of research, usually involving human or animal experimentation. Research ethics and integrity principles are used as guidelines for situations like academic scandal, scientific misconduct, and research regulations. Why might ethics in research be important? I want you to think about this question before we move on. Now, I want you guys to participate in a class discussion. So, as a class, come up with a research question. This can be about anything, any topic, and then I want you to create a general research design. How would you try to answer this question or test the hypothesis? Then I want you guys as a class to create a general research design. How would you try to answer this question or test the hypothesis? Think about data analysis and interpretation as well. Then I want you to come up with 2 ways that there could be a breach in the ethics or integrity of research. Go ahead and pause this video and take about 20 to 30 minutes for this class activity. So, what are some ethical risks to consider in research? As a researcher, you must be aware of these risks to participants. Well being is one of them, and well being is understood as their health and welfare. Next, autonomy is their freedom and ability to make their own decisions. Then, justice is fairness, treating them equally and fair. If your project involves any of these potential risks, you will need to think about them and how to address them. So, some questions deciding if you have ethical risks in your research would be, will any of your participants be vulnerable? For example, are any of them under 16 years of age, unable to communicate in the language, members of a stigmatized or marginalized social group, have a relationship with the researcher either personally or professionally? How will you show that any participants have agreed to take part? Will they be able to give informed consent individually? Will consent need to be obtained from parents or guardians? Will the purpose of your research be concealed from participants at the outset? Are you collecting personal data either face to face or online? If so, how will you obtain the consent of participants? How will this be securely stored and maintained? How will this data be used? With whom will it be shared? How and when will it be disposed of? These are all questions and things to consider when deciding ethical risks in your research. Now let's talk a little bit about research ethics in agriculture. There are 4 main aspects of agricultural research which are incredibly important when it comes to ethics. These 4 aspects are people in the food industry, public citizens, farm animals, which are the food supply, and the living environment. Ethics in agricultural research means making choices that are fair, safe, and respectful to people, animals, and the environment. So, four main areas of focus include consumers and producers, which are families make smart food choices and farmers ensure food safety and quality. Community engagement, which includes encouraging healthy eating and supporting local food programs. Third, being farm animals in the environment. This will promote animal care and eco friendly farming practices. And lastly, nutrition and wellness. This will highlight the importance of balanced diets and healthy lifestyles. Now, this table shows the different factors of ethics that affect well being, autonomy, and justice for people in the food industry, citizens, farm animals, and the living environment. Some of these things for well being would include income and working conditions, food safety and quality of life, animal welfare, and conservation. Autonomy, meaning freedom of choice, include freedom of action, democratic informed choice, behavioral freedom, and maintenance of biodiversity. And lastly, justice and fairness, fair trade laws and practice, availability of affordable food, instinct value, and sustainability. Now let's discuss some examples of agricultural ethical issues. So for food safety, producers taking shortcuts or using questionable additives makes food unsafe. Recalls are common, especially with produce, and food recalls are up by 10% since 2013. The treatment of animals, many have a difficult time seeing this as an actual ethics issue facing the agricultural industry. If animals are just being used as a food source, why treat them well? But this also includes using steroids and hormones to produce growth and production. Unethical treatment leads to lower quality products, meaning it's worth investing to treat animals better. Next would be chemical use. The use of pesticides and other chemicals has been an ongoing debate. Farmers want to use chemicals to reduce pests and increase production. However, those same chemicals have been known to cause health issues. Plus, pesticides are killing off native species and decreasing biodiversity. These are just a few of some really important examples of agricultural ethical issues. There are, of course, many more. To make sure we are practicing ethical research, there are three main considerations we must take. The first being authorship. Always give credit due to authors and never plagiarize another author's work. Data management. Data from research involving private information should always be documented and stored in secure locations. Human and animal welfare. Researchers must always treat human and animal subjects humanely and ensure that human subjects are informed of their study participation, which is informed consent. It's important to note that these are just some of the core practices. We are wanting to highlight the human and animal welfare. Conducting human or animal research, certain precautions need to be taken to make sure there are no risks. Let's look at this video that talks a little bit more about it.
We know a lot about the human body, what's in there, how it works, and how to heal it when it's sick. But of course, this wasn't always so. It's really only been in the last few centuries that scientists have been able to explore and experiment on humans. I mean, rats and mice may be a good place to start down on the road to new discoveries, but after a point, to really learn about humans, you have to try stuff out on humans. And as you might expect, human testing is currently and has always been a tricky business. At their best, researchers have searched for life-saving cures and treatments for uncomfortable and deadly conditions. At their worst, human studies have edged into dark, curiosity-satisfying torture experiments that yielded few useful results. When it comes down to it, the science performed on humans has ranged from good to bad to very, very ugly. Way back in the day, physicians like Aristotle got most of their information about our bodies from a combination of dissecting other animals' bodies and guesswork. But you can study monkeys and pigs all you want and not get a very good picture of what's really going on all up in here. So one of the very earliest uses of the human body in science was the simple study of human anatomy. For more than 1,000 years, it was one of the most controversial areas of scientific research. This may in some part be because, ethically speaking, anatomical study got off to a very bad start. Around 2,300 years ago, Greek physicians Herophilus and Erasistratus got to see the inside of human bodies when they obtained permission to carry out live dissections, or vivisections, on criminals. Herophilus was also the first known person to perform autopsies, and his descriptions of the nervous, digestive, reproductive, and cardiovascular systems remained important, and in some cases singular, until the Middle Ages. But working on human bodies, living or dead, was widely considered taboo. Many contemporaries considered Herophilus to be a sadistic butcher, and people thought poking through the guts of even a dead person would anger the gods. By the time Roman law came along, human dissections of all types were banned, and the taboo of studying the human body remained in place for the next 1,600 years. It wasn't until the late 15th century when Michelangelo, Leonardo da Vinci, and Antonio Pollaiuolo started making secret anatomical drawings of cadavers that the scientific mind began once again to probe our inner workings. Still, human anatomy wasn't taught in universities until the mid-1620s, and dissection was regarded warily even then. It wasn't until England's Murder Act of 1752 that surgeons in that country were allowed to dissect the bodies of executed criminals. But it was around this time, when scientists were finally able to address the essential questions of what goes where inside us, that the idea of actually experimenting on people became at least thinkable. Perhaps the most famous and important early example of human experimentation is the origin of the smallpox vaccine. In 1796, English doctor Edward Jenner was seeing a lot of smallpox patients. Lots of pus, lots of dying. He started thinking about the folk adage that people who caught cowpox couldn't catch smallpox. Cowpox is a mild viral infection seen in cows, and other than getting some pussy pox on your udders, it wasn't so bad. Milkmaids sometimes caught cowpox, on their hands in particular, after milking infected udders, and while it made them feel nasty, it wasn't a big deal. So one spring day, Dr. Jenner got a patient with cowpox on her hand, and he is all, aha, an opportunity to infect an unsuspecting human. Then the gardener's 8-year-old son walked by. Jenner scratched up little Jimmy's arm and rubbed some pus in there. The kid got mildly ill with cowpox, but was fine a week later. Jenner then knew cowpox could be passed from person to person, as well as from cow to person, and presumably cow to cow. But the big question was about smallpox, so Jenner infected the boy again, this time by injecting the smallpox pathogen into him. What? And to his, the kid's, and presumably the gardener's great relief, he was immune. Just to be sure, though, Jenner then tested his methods on other neighborhood kids, including his own infant son. Eventually, the medical community and the public accepted what Jenner had discovered, a vaccine, from the Latin for cow. Vacca. In the end, Jenner made history, and luckily no humans were maimed or killed in the process. It's a good example of successful human medical experimentation. Other cases are more complicated. In fact, this case is kind of more complicated because if he had failed, he would have just been murdering people. But let's look at the case of Alabama doctor J. Marion Sims. Originally lauded as the father of gynecology, history isn't sure what to make of him now. In the mid-1800s, Sims discovered how to operate on collapsed uteruses and how to close up fistulas, or tears in inner tissue suffered during childbirth. These were serious problems that killed or made miserable many women at the time, and Sims pioneered the operation that fixes them. But he tested his technique on slave women, often without anesthetic, even after such drugs became widely available. He operated on one woman at least 30 times. Sad to say, the practices on human subjects didn't improve much in the 20th century when many doctors conducted their experiments on prisoners, poor folk, soldiers, and mental patients. Some of this work had good intentions, but some of it was just weird. Like back in 1920 when a resident physician at San Quentin Prison in California tried to revitalize older men by implanting them with the testicles from younger executed convicts and even livestock. Of course, No one did evil experimentation quite like the Nazis, except maybe their equally morally bereft Japanese counterparts in the infamous Unit 731 Secret Research Unit during World War II. I'll let you research these atrocities if you want yourself, but suffice to say there were many trials involving vivisections without anesthetic, forced sterilization, exposure to extreme temperatures, deadly pathogens and chemicals, and other totally messed up stuff. Today, it's impossible to view any of these experiments as anything more than torture thinly veiled as medical research. When the war ended and the world learned what the Nazi researchers had done, the Nuremberg war trials began, and from them we got the Nuremberg Code, a set of international rules outlined to protect human test subjects. The code, I know, revolutionary stuff, stated that the subject's voluntary consent without coercion is essential. Surprise! Really? Did it take us that long to figure that out? Also, that the subject can end treatment at any time, that only licensed professionals should carry out treatments, and they should terminate their study if the subject is in danger. But many US doctors believe that these rules only applied to war crimes and apparently not their own research. So a boom in prison populations, combined with the rise of pharmaceutical and healthcare industries, led to tons of corporate and federally funded experiments on prisoners. By the 1960s, at least half of states in the country allowed medical testing on prisoners, and about 90% of all pharmaceutical testing happened there. Meanwhile, some doctors were taking liberties outside of prisons too. In 1963, Dr. Chester Southam injected cancer cells into around 20 elderly and infirm patients at the Jewish Chronic Disease Hospital in Brooklyn to see if their bodies would reject the cells the same way healthy bodies did. The patients were not asked for permission, they weren't even told what was happening. Around that same time, word got out that researchers were infecting mentally disabled children with viral hepatitis at Staten Island's Willowbrook Institution to test new treatments. The researchers found that the disease could be blocked with injections of the blood protein gamma globulin, but conditions were so inhumane that the institution was shut down, hardly a shining victory for science. The final straw came in 1972 when news of the notorious 40-year-old Tuskegee experiment hit the press. The study began in 1932 when the Public Health Service of Macon County, Alabama, and the Tuskegee Institute wanted to observe the effects of untreated syphilis. In exchange for free meals, medical exams, and burial services, nearly 400 poor syphilitic African American men enrolled in the study and were told they were being treated for bad blood. They were not informed that they had syphilis. They were never treated for it, even after penicillin became a standard cure in 1947. Instead, the researchers observed how the disease progressed and ultimately killed over the years. Meanwhile, many of the men went home and inadvertently infected their families. Combined, these stories proved too much for the public and the government got involved. By the mid-1970s, the US banned all outside research in federal prisons and cracked down on human subject experimentation. In response, many research outfits and drug companies simply moved their operations overseas. In 2008, the U.S. Department of Health and Human Services estimated that as much as 65% of clinical trials of federally regulated drugs were done in foreign countries. Virtually none of those tests were closely monitored. Now, none of this is to say that a lot of good life-saving treatments haven't come out of human testing. Virtually all of the big ones, from blood transfusions to vaccines to organ replacements to space exploration, had to be tested on humans at some point. It's just that experimenting on humans can be a slippery slope, and that's why, in recent decades, some researchers have avoided this sticky wicket of experimentation on other people by experimenting on themselves. Bruce Banner style. The tradition of self-experimentation probably most famously began with the amazing husband and wife team of Pierre and Marie Curie, who in the early 1900s exposed themselves to lots and lots and lots of radiation while researching the elements they had discovered, uranium and radium. Pierre, for instance, strapped radium salts to his arm for several hours, then observed the resulting burn change over the course of several weeks. They were constantly sick, tired, and in pain, but the Curie's research ushered in the use of radiation in medicine and earned both of them a Nobel Prize, and unfortunately eventually killed Marie. Taking a cue from the Curies, decades later in the mid-1980s, Australian doctor Barry Marshall and pathologist Robin Warren sought to refute the theory that stomach ulcers were caused by lifestyle factors like stress and poor diet. They believed that the bacterium Helicobacter pylori was the culprit. To test this theory, Marshall decided to take one for the team. Fearing that the hospital's ethics committee and his wife would shoot his idea down if he asked, He just knocked back a petri dish and swallowed a healthy dose of the bacteria. 4 days later, he started puking and developed some serious death breath. Biopsies confirmed that the bacteria had taken up shop in his stomach and that he'd contracted gastritis, which eventually may lead to ulcers. But the yuck factor eventually paid off. Marshall and Warren earned the 2005 Nobel Prize for Medicine for their breakthrough contributions, and probably a stern talking to from Mrs. Marshall. Speaking of unhappy guts and self-testing, in 2004, Dr. David Pritchard strapped some larvae to his arm to infect himself with parasitic hookworms to prove that the presence of these gut parasites significantly decreased the symptoms of autoimmune diseases. While doing fieldwork in Papua New Guinea in the late 1980s, Pritchard noticed that natives infected with hookworms were largely unaffected by illnesses like asthma and seasonal allergies. He theorized that somehow the worms switched off the immune system response, and in the process, the immune system didn't overreact with allergic symptoms. Before he could get approval from regulators in Britain to recruit wheezy, sneezy volunteers, he used himself as the subject and learned some important stuff. Turns out 50 hookworms are too many and make you sick, but 10 is just the right amount to avoid intestinal discomfort and allergy symptoms. Soon, he had a steady stream of human test subjects knocking on his door, inviting worms to get cozy in their intestines. Hopefully, in addition to learning more about our physical selves, we've also learned more about our moral selves. There will likely always be a need for some level of human testing. A lab rat simply can't stand in for everything. But researchers and regulators alike can take one very old piece of advice, because Hippocrates really did have it right. Primum non nocere. First, do no.
For human research, informed consent is normally given by a participant or patient to a doctor or researcher. The patient gives consent that they are aware of the potential risks and effects of whatever treatment they will undergo. One common practice is to give participants an informative consent form that describes the nature of the research project as well as the nature of the participant in it. The participants just need to have permission granted with all the knowledge of the possible consequences. This is an example of a human-informed consent form. So these will contain disclosure of information, competency of the participant to make a decision, voluntary nature of the decision, and documentation of the consent. So a consent form will include the student researcher's names, the title of the project. It will then explain the purpose of the project and how you are asking for participation. It will also ask you time required for participation and potential risks as well as benefits of the study. It needs to be explained how confidentiality will be maintained. It will also need a contact information of an adult sponsor. Then it will need to have signed and reviewed with a date, as well as a parent or guardian permission with sign and date. So, who created the need for these informed consent forms? Who makes sure that researchers are doing these forms and conducting research ethically? And that's where research ethics review committees come in. We're going to talk about 3 different ones: IRB, IACUC, and IBC. In the US, Canada, and some of Europe, any college, university, or research institution must have Institutional Review Boards, IRB, that scrutinizes all proposals for conducting human research under the supervision of the institution. Research proposals must be submitted to and accepted by the IRB before any data are collected for the project. An IRB consists of at least 5 members of varying backgrounds. IRB members should have the professional experience to provide appropriate scientific and ethical review. An IRB must have at least 1 scientist member and at least 1 member whose primary concerns are non-scientific. Why do you think this is the case? Just think about this question for a little bit, about why an institutional review board would need to review research before continuing. Similar to IRB, we have Institutional Animal Care and Use Committee, which we call IACUC. Researchers must submit their animal use protocols to their institution's IACUC for approval. IACUC reviews the animal use protocols and proposes that researchers intend to use. Any research that may be potentially cause suffering, distress, or death to animals must be described and justified to Iacuk. The researcher must minimize or prevent suffering or death to the extent that is possible to do so. Iacuk consists of at least 5 members and includes one veterinarian with training and experience in laboratory animal science and medicine, who has direct authority and responsibility for activities involving animals at the institution. One practicing scientist experienced with research in animals, and one member whose primary concerns are in a non scientific area. Ethics, lawyer, or clergy member could be one. And also one member who is not affiliated with the institution other than as a member of Iacuk. When researchers are approved, they may begin their research study. So anything using animals for research, they have to be approved before beginning their study. Lastly, let's talk about IBC, Institutional Biosafety Committee. The IBC must review and approve all research and teaching projects involving hazardous biological materials, including recombinant DNA as defined by an institution guidelines and including transgenic animals and plants, select agents and toxins specified by the institution, some human or zoonotic pathogens, strict animal and plant pathogens that are either reportable or non indigenous to the area of the institution. Like IRB and Iacuk, the IBC functions to review research proposals and protocol involving potentially dangerous aspects. IBC consists of many members, all experts or specialists in various fields like infectious disease, safety services, public health, or biology. IBC members may be doctors, consultants, or committee members invested in the biosafety of research. These 3 boards and committees are different, but they have some similarities. So for Iacuk and IBC, they share animal safety. IBC and IRB also share human safety. They are all interconnected and deal with similar ethical issues. These 3 boards help to make sure that agriculture research and other animal and human research is done in an ethical and humane way. Now, I want you guys to participate in another class discussion. Take a look at the headlines below and decide which review board must have given permission for these research experiments. 1. Human cured of HIV after human umbilical cord blood transplant. 2. In a first, a robot performs a laparoscopic surgery on a pig without human help. 3. Doctors transplant gene-modified pig kidneys into brain-dead patient. And 4. New species of corn developed using genome manipulation will allow farmers to use less water and fertilizer while maintaining crop yields. Pause this video and talk about this with your class or group, and I'll be back with the answers. So, I hope you all have discussed these 4 headlines. For number 1, the answer is this woman cured of HIV after human umbilical cord transplant would need a review of the IRB. Number 2 would need IRB and Iacuk. Number 3 would need IRB, Iacuk, and possibly IBC. And number 4 would need IBC. Also, all of these headlines below are true. So this is very interesting and good to think about in a real world problems for deciding which review board you might need for your future research. So that includes Lesson 4, Part 1. In Lesson 4, Part 2, we will discuss how to be an ethical researcher and research misconduct, the consequences, and how to avoid it.